All right, good day, everyone. Welcome to this channel. Uh, Today we are going to pick it up from where we'll stop. In our last class, we were able to give an introduction to amino acids. We are able to understand the definition of amino acids. We also look at different forms of amino acids, and we look at the L form of amino acids. We look at the ionized form of amino acids as well. And we got to understand that the most stable amino acids or form or structure of amino acids is the ionized structure of amino acids, and also the L form of amino acids are the most stable forms and structures of amino acids. All right, today, as promised, we are going to be looking into the structures of each structures of the 20 amino acids we listed out in our last video. If you haven't watched it, I will advise you to go and check it out uh, because it will help you to understand what we'll be doing today as well. When you watch it, you can come join us as well. All right, let's continue. We made mention of alanine. We made mention of cysteine aspartate, or you call it the aspartic acid. I told you you can call it alternatively aspartic acid, or you call it the aspartate. Uh, we have the glutamate. You can call it glutamic acid as well. We have the phenylalanine. We have glycine. We have histidine, isoleucine. We have lysine. We have serine. We have proline. We have tryptophans. We have tyrosines. We have uh, histidines. We have leucine. We have serines. We have valines, and we have so many of them: asparagine, methionine. We have lysine as well. So you can check the list for yourself. We have threonine as well. So these are the 20 amino acids we made mention of in our last class. Today we are going to look at the structures of these amino acids. Students find it very difficult to comprehend or memorize these structures. Of course, looking at them, they are very complicated. Some of them are very similar, as you be wondering how you'll be able to understand the chemistry behind the structures. When you want to draw them, we often mix them up. But today, I'm going to be helping us with a trick that will help us to memorize the structures of this amino acid very, very easily. All right, before that, there is a very good pattern I use. If you We have a specific way or pattern of numbering in Greek. We start our numbering from alpha. We have the beta. We have the After the beta, we have the gamma. After the gamma, we have the delta. After the delta, we have the epsilon naught, and so on and so forth. All right, so we are going to be making use of that very pattern as well. Remember from the explanation in the other class, in our last class, we say the second carbon atom here is known as what? The alpha carbon. We say it is the alpha carbon. Are you getting it? It is the alpha carbon. All right. So now, if we move into another carbon, is going to become a beta carbon. If we now move to another carbon, is going to be the gamma carbon, the next one, the delta carbon, and so on and so forth. Okay, so we are going to make use of this trick to easily memorize the structures of amino acid. I'll write it in form of a molecular name that will help you to easily recall the structures. All right, so we have aniline, we have the CH3 attached to the central carbon atom, that is the alpha carbon here. So we can abbreviate the structure of alanine to be alpha methyl. You know, from our organic chemistry, our CH3 is called the methyl. So we can just say alpha methyl. So when we say alpha, it's we have the alpha carbon and we have the CH3 attached to the alpha carbon. So with this abbreviation, you easily recall the structure of alanine. Okay, all right, let's proceed. We have what we called the cysteine. Cysteine, we have this very one to be the alpha carbon. This is the alpha carbon. This is the first carbon. This is the second carbon, and we call it the alpha carbon. And as a matter of fact, is the first carbon atom. We call it the carbon one in terms of this trick I'm showing you now, if you want to use it. So we don't start our numbering from the carboxylic group here. Are you getting it? So this becomes the first one, the second one. Okay, so this first one is called the alpha carbon, and the second one here becomes your beta carbon. So on beta carbon, we have these constituents. Okay, we have this attachment. This is sulfur hydride. Okay, so we can abbreviate the whole of this structure to be beta beta so this is sulfur sulfur is sulfur hydride. Sulfur hydride. I hope you can get it, or better still, you can just shorten it to be beta SH in a more simple sense. Okay, all right. So with this now, you can easily recall the structure of your cysteine. Okay, it's having a sulfur hydride SH attached to the beta carbon. Are you getting it? So that is how to easily recall it. We have another amino acid we call the aspartate. I told you you can also call this aspartic acid. Okay, it is a conjugate of an acid, so we call it aspartate. And you can also call it the aspartic acid as well. The two names, either of the two names are correct. Uh, let's look at the chemistry behind the structures. This very one, we say this is the alpha carbon, right? This becomes the beta carbon. So on the beta carbon, we have the carboxy group. Okay, so it's going to be beta carboxy. Are you getting it? Beta carboxy, beta carboxy. So this is just a short way to remember the structure of aspartate, or you can just say beta COO minus. Okay, so this is just a short way, short trick to recall or remember the structures for the sake of exam, because you find it very hard, boring as well, bulky as well uh, to cram the structures of these amino acids. Of course, if you're not careful, you are going to mix them up. But with this little abbreviations, you with this trick rather, you'll be able to record them very well. All right, at this point, if you haven't liked the video, uh I'll plead with you to do so, and also to subscribe. Just give me a like thumb and subscribe to the channel. If you subscribe is not reducing anything from you, it's just to give you notification when we drop another video again. So do it to subscribe as well. Let's continue. All right, the next amino acid is glutamate. You call it glutamate or you can call it glutamic acid. So the two names are correct. Alternatively, you can use anyone. We have the alpha carbon here. We have the beta carbon here. After beta, what do we have next? We have the gamma. Okay, we have the gamma here. All right, so on the gamma carbon, we have this attachment. Okay, so it's just going to be gamma carboxy. Is gamma carboxy or gamma gamma COO minus. I hope you're following. The next one here we have is your phenylalanine. We have phenylalanine. Phenylalanine is an aromatic amino acid. Okay, it is an aromatic amino acid because it's having an aromatic ring attached to one of the carbon atom in the structure. All right, the first carbon here we have the alpha carbon. We also have the beta carbon. It's on the beta carbon that we have this ring, and if you understand your chemistry very well, you agree with me that this ring is a benzene ring. Okay, so we can say abbreviate the structure as beta benzene. Okay, this is beta benzene. I hope you're following. This is beta benzene. I think there's E in benzene. This is beta benzene. This is beta benzene. All right, so or better still, you can just use the structure to represent it. This is beta, and you have something like this, like this, and also like this as well. So this is just the structure of benzene. Okay, so this is beta benzene. On the beta carbon we have the benzene attached to it. We have another one. We have the glycine. We have glycine. We have alpha carbon here. On the alpha carbon we have this attachment attached to it. The reason why we are not considering these very ones, this other attachment, this hydrogen, this one, and this very group as well, is because already we know from the structure of amino acid these ones are constant already. Okay, the only thing that change in the structure of amino acids is the side chain. Are you getting it? Is the side chain that help us to differentiate between the structures of amino acids. Are you getting it? Whenever we move to the next amino acid, something will change in this side chain. Okay, look at what was the side chain. The side chain that was here is supposed to be an R group here. The whole of this place, the whole of this group now came to replace the side chain. I hope you're following me, right? Good. All right, so for your glycine, we have this group attached to the alpha carbon, and we can abbreviate it or shorten the name as alpha hydrogen. Okay, alpha hydrogen. Better still, you can say alpha H. I hope you are following. So this is just the structure of glycine, and as a matter of fact, it is the simplest amino acid. Okay, it is the simplest amino acid. It is the simplest amino acid. I hope you're following. It is the simplest amino acid. You should take note of that. It is an objective question. It might decide to ask you the simplest amino acid. To name the simplest amino acid, it is glycine. Okay, and we say something about this glycine in our last video we said glycine is the property that it has is symmetric. That is to say it is not optically active. Okay, it is not optically active because of its symmetric properties, or other in other words you can say it is not optically active because it lacks asymmetric properties. It cannot rotate light. It cannot rotate light. Okay, it cannot rotate light. I hope you're following, right?